Another F naught equals ma question. Another force on an angle, but this time it is below the horizontal. That'll change things subtly, but the same method will get us through this. Hopefully it's becoming a little bit routine. When given an F naught equals ma style of question, we're going to draw the free body diagram. In this case, it says the applied force is 30 degrees below the horizontal, so it's going down here. And we're pushing with a force of 50. The given angle is 30. We've got a normal force. We've got gravity. And it mentions a coefficient of friction, so we've got some friction. Probably I should rethink this. We usually don't talk about coefficients of frictions on things with wheels like lawnmowers, but let's just ignore that part and we'll grind it out, and maybe there's a sticky wheel so it's sliding across the ground or something, but we'll figure out what kind of friction, what coefficient of friction would make this happen. Kind of like we did before, we have to break that force that's on an angle into its two components. Since it's not moving on a funny angle, it's moving horizontally. The horizontal and the vertical are the important ones. Opposite the angle is going to be a sine relationship. Adjacent to the angle is going to be a cosine relationship. To figure out the coefficient of friction, I need to know the normal force, so I'm going to start with the vertical. It's not a boring scenario. We've got up forces and downward forces. They need to completely cancel each other out. In this case, what's different, since we're pushing it below the horizontal, I've only got one upward force. That's the normal. There's two downward forces. Gravity's pulling it down, and that component of the applied force is pushing it down. The normal has to be larger than it usually is to cancel out, to take into account the fact that we're pushing it downward. Plugging in some numbers, the mass of this lawnmower was 10 kilograms. 50 sine 30, you could do that in your head, that's 25. When we eventually get it to a number, I'm getting that the normal force is 123. Going to carry that forward into the horizontal. I could set up F net equals ma in the horizontal, but another thing about this question is it says it's going at a constant speed. So I could set up F net equals ma and say that the a is 0, or I could just kind of look at it and say, since it's going at constant speed, the forward force must completely cancel out the backward force. That's kind of how I set up the vertical. The up force and the down force have to balance. Horizontally, since it's going at constant speed, it's not accelerating. The forward and the backward have to balance. The forward force is that component of the applied force, 50 cosine of 30. The backward force is the force of friction. 50 cos 30, I can crank that out to a number, or I could sub in. FF is the same as mu times Fn. Calculator work, this is the way I did it when I practiced, so this is the way I'm going to do it in our little video. Mu times 123. If I clean that up, my coefficient's going to be the 50 cos 30 number. Crank that out on your calculator, divided by 123. When I did it, I got roughly 0.35. Same type of question, same method to solve it. We just had to watch our directions since this one is being pushed below the horizontal.